Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Diazonium salt formation and azo coupling reaction. P-toluidine, 4-methylaniline, reacts with nano to HCl at 0 to 5 degrees Celsius to form the diazonium salt, 4-methylbenzenediazonium chloride, compound A, 4CH3C6H4N2+, Cl. Moving on to the next step. Azo coupling with phenol in mild basic medium. In mild basic medium, slightly alkaline, example, pH tilde 8-10, phenol is converted partially to phenoxide ion, PHO, which is a much stronger activating group for electrophilic aromatic substitution. The diazonium ion acts as a weak electrophile and couples with the activated aromatic ring. Moving on to the next step. Phenoxide ion directs electrophiles to ortho and para positions. The para position is preferred over ortho because it is less sterically hindered. Therefore, the diazonium salt couples at the para position of phenol, i.e., para to the OH group. And for the final step, the product is 4-hydroxyphenyl azo 4-methylphenyl, i.e., OC6H4N is equal to NC6H4CH3, para, where OH is at the para position of one ring and CH3 is at the para position of the other ring. This corresponds to option B. A. Incorrectly places the azo group on the methyl-bearing ring with no OH group and involves unactivated benzene as the coupling component wrong. C. Shows a direct C to C bond to pH rather than an azo linkage, wrong product type. D. Shows coupling at the ortho position to O, which is the minor product, the major product is para coupling. Therefore, the correct answer is B. Therefore, the correct answer is option B.